Again, the major axis is along the y-axis. It's going from -4 to 4. The minor axis is along the x-axis going from -3 to 3. So the length of the minor axis is 6. So here we have our ellipse in standard format. Again, we know it's an ellipse because it has an x squared and a y squared term. Both of them are positive, but they have different numbers either next to them or below them. In other words, they have different coefficients, the x squared and the y squared. Okay, so let's look at question number 11. Just put it over here. Question number 11 gives me the equation 4x squared plus 25y squared equals 100. I recognize this also as the equation of an ellipse. Again, I have an x squared term, I have a y squared term. They're both positive. This is a positive 4, this is a positive 25. This equation is not in standard form, but the coefficients of the x squared and the y squared are not the same number. That means that we have an ellipse. How do we draw this ellipse? So when we want to get something that's not in standard form, we want to graph it. The first thing we want to do is put it in standard form. And the way we put it in standard form is we divide by the number on the right side of the equation, because in standard form, you have to have it equal to 1. So in order to get this equal to 1, I'm going to have to divide this by 100. But whatever I do on one side, I have to do the same thing on the other side. So I'm going to have to divide this by 100 and this by 100 as well. And I reduce. So the 4 and the 100 have a common factor of 4. I cross out the 4. 100 divided by 4 is 25. The 25 I can cancel into the 100, and that gives me 4 on the bottom. So that, and of course, this becomes a 1. So in standard format, this equation becomes x squared over 25 plus y squared over 4 equals 1. Notice it sort of switches. What was originally next to the y becomes the denominator of the x. Okay, once we have it in standard form, we can do what we did before. We'll get our x-intercepts by taking the a squared, which is 25. The a squared is always a number that's underneath the x squared, which will give me that a is either positive or -5. So we have two x-intercepts, 5 and -5. My b squared is a number underneath the y squared, happens to be 4. That means the b can either be +2 or -2. My y-intercepts are either 2 or -2. And now we can draw this ellipse. Let me draw it over here. Here's my graph. We said that the x-intercepts are 5, 1, 2, 3, 4, 5 to the right, and -5. And my y-intercepts are 2 and -2. So here's my ellipse. Notice, in this case, my major axis is along the x-axis and my minor axis is along the y. Again, the major axis is horizontal and it's 10 units. The minor axis is vertical or along the y-axis and it's 4 units. So always double what the A and the B are, because the A and the B are telling you how much to go from the center to the edge, and the axis is from edge to edge. There is another question. 12 is very similar to this. You do the same thing. You divide everything by 32 and you put it in standard format. But 13 is a little bit different. So let's look at example number 13. In number 13, we're told that the major axis is 10 and lies along the x-axis, and the minor axis is 8 and lies along the y-axis, and they want the equation of the ellipse. So let's just draw it, and then we'll be able to figure out the equation. Since the major axis is 10 and it's along the x-axis, it means it must be 5 in each direction, because the center, it's going 1, 2, 3, 4, 5, 5 to the right, and also 5 to the left. That's my major axis. My minor axis, they said, is 8, which means that we're going, and it's along the y-axis, which means we have to go up 4 and down 4 for a total of 8. So this is the point 0, 4. Remember, when you're on your y-axis, your x is 0, and this is 0, -4. So now we have a picture of what's going on here. Here is my ellipse. Okay, so we have this ellipse. We want to know the equation of the ellipse. So writing the equation in standard form is really not too hard. The A is either 5 or -5. Doesn't matter which you pick. So the A squared is going to be 25. No matter whether you pick the positive or negative, when you square it, you're going to get a positive number. The B is the y-intercepts, can be either plus or -4, which means that B squared is equal to 16. So my equation in standard format becomes x squared over 25 plus y squared over 16 equals 1. Okay. That would be the answer if this was an open-ended question. Now, what if I had given this as a multiple choice question? And let's say these are the choices I gave you. One choice is x squared over 16 plus y squared over 25 equals 1. One choice is 16x squared plus 25y squared equals 400. Another choice is 25x squared plus 16y squared equals 400. And suppose for choice D, I give you x squared over 5 plus y squared over 4 equals 1. And I look at all these choices, and not one of them matches the choice that I gave you. How am I going to figure out which is the correct answer? Well, there are two ways of doing it. I could multiply this whole thing by the common denominator and get rid of the fractions. But I think if this is a multiple choice question, I can see if there's some answers that I can right away eliminate, and then let me see what I could do with the other answers. So obviously answer number A is not right, because this is x squared over 16 and we need x squared over 25. So cross out choice A. Similarly, choice D, I'm going to cancel out because it says x squared over 5. It doesn't say x squared over 25. This is also, these were both written in standard format, and neither of them was the right answer. So I have these two choices that are not in standard format. And don't make the mistake of saying, oh, it must be choice C because I see the 25 with the x squared. No, what you must do, these are not in standard format, put them in standard format and see which one matches your answer. How do we put this in standard format? Well, obviously here we have to divide everything by 400 because we have to get it equal to 1. So for choice B, we're getting 16x squared over 400 plus 25y squared over 400 equals 400 over 400. And I reduce this. The 16 divides into the 400 and gives me 25. The 25 into the 400 gives me the 16. And the 400 into the 400 gives me 1. So this in standard form, choice B is x squared over 25 plus y squared over 16 equals 1, which is what my right choice is. This is the correct answer. Notice it sort of switches. What was on the bottom of the y squared becomes the coefficient of the x squared, and the 25, which was on the bottom of the x squared, becomes the coefficient of the y squared. So that's 16x squared plus 25y squared. It's sort of cross multiplying, but of course 25, this side is not equal to 1, it's equal to 400. So if you have a multiple choice question and it's not, your answer is not in the format that you're normally used to, put your answers in the standard format so you can compare it with your correct and see which is the correct answer. Okay, so that takes care of the ellipse. So the other thing that we talked about on Thursday was something called the hyperbola. So let me erase this and let's talk about the hyperbola. The standard equation for a hyperbola is there one of these two formats: x squared over a squared minus y squared over b squared equals 1, or y squared over b squared minus x squared over a squared equals 1. If you notice, it looks very similar to the equation of the ellipse, except between the x squared and the y squared terms, there's a minus instead of a plus. In other words, whenever you have an x squared and a y squared term in your equation, and one of them is positive and one of them is negative, you're going to get a hyperbola. And when you have a hyperbola, you don't have both x or y and y intercepts. You only have one or the other. When the x squared is the positive one, then you have x intercepts and no y intercepts. That's because if you would try to solve for the y, you'd get a y squared equals something like negative 25. And when you get a negative, then your answer comes out to be in terms of I, and that you can't graph that. So when the x squared is the positive one, you have an x intercept. When the y squared is the positive, then you're going to get y intercepts, but no x intercepts. And again, here the x-intercepts will be plus or minus a, no y-intercepts. Here your y-intercepts will be plus or minus b, and no x-intercepts. And all you have to do is be able to recognize what the graph looks like. So let's say I gave you, I'm going to do two examples. Example number 1, let's say I gave you, let's do number 15. Suppose I gave you y squared over 25 minus x squared over 4 equals 1. Now I recognize that this is in standard form, and I recognize it's a hyperbola because I have an x squared and a y squared term, but one is positive and one is negative. And in this case, the one that's positive is the y squared, which means I'm going to get y intercepts. I'm not going to have any x intercepts. And I'm going to find the y intercepts by doing b squared equals 25. So the b will have to be plus or minus 5. So my graph will look like this. I have two y-intercepts, 5, which is obviously 0, 5, and negative 5. It's not crossing the x-axis at all. There is no x-intercept. You get two curves that sort of face away from each other. They're two U-shaped things, but they're facing at opposite directions. In other words, the hyperbola has two branches. They don't touch. This does not connect to this. They just look like two U-shapes, one U facing up, one U facing down. Sometimes the U's are narrower, sometimes they're wider. How you figure that out is beyond the scope of this course. There are ways of figuring out whether you should make it a wide U or a narrow U, but that is not something that you have to know how to do at this point. If I gave you example number 16, we have 16x squared minus 9y squared equals 144. I recognize this as a hyperbola because I have an x squared and a y squared term, but the sign one is positive and one is negative. In this case, since it's the x squared that's positive, it means that we have x-intercepts, no y-intercepts. In order to find the intercepts, we're going to put this in our standard format. This is not in standard format because it doesn't equal 1. So I'm going to divide everything by 144. Okay, and simplify this. So 16 goes into 144 and gives me 9. 9 goes into 144 and gives me 16. And 144 into 144 gives me 1. So in standard format, we get x squared over 9 minus y squared over 16. You see how the numbers sort of switch? What was on top for the x squared becomes the denominator for the y squared. I'd say that happens in 99% of the time. And of course, that equals 1. Well, in any case, now we're in standard format. We see our x squared is the positive one. So we're going to find our x-intercepts by doing a squared equaling 9, because the number underneath the x squared is 9, which means the a has to be either positive or negative 3. And then I go 3 on the positive x, and then 3 to the left to get to the negative 3. And again, I get these U shapes facing away from each other, one this way and this way. In other words, we have x-intercepts, but no y-intercepts. And that's what you have to know in terms of the hyperbola. You have to be able to recognize the hyperbola. You have to be able to find its intercepts. And again, there are only going to be 2 intercepts, either 2 x-intercepts or 2 y-intercepts, depending on which one is the positive one. So, unless there are some questions, we've now reviewed how to graph circles, hyperbolas, and ellipses. And there's one type of conic section left to discuss, and that is what is a parabola, and how do we recognize that we have a parabola, and what does it look like, and how do we graph it? In other words, let's talk about parabolas. Okay, and I'm going to do one example for you, and then I'm going to give you time to try one on your own. Okay, I'm going to erase all this stuff because it's just taking up too much of my board. I hope everybody has it down pat. I'll leave the homework on the board because that you still need to know. The homework is going to be on the parabola. The general equation of a parabola is y equals ax squared plus bx plus c. If you notice, what's important, the most important thing to notice here is we do have an x squared term, but there's no y squared term. The parabola is the only one of the four quadratic equations that only has one of the variables squared. The other one is not. Now, the standard look of a parabola is a U shape. Usually it's a U shape up, or sometimes it's facing downward. You can have parabolas that are sideways. You could have one this way, you could have one this way. If you notice, it looks a little bit like the hyperbola. It's not exactly the same shape. It's a little bit more pointy, but it's basically that same type of curve, except it's only one. They're not two. In a hyperbola, you have these two, I'll call them C shapes or U shapes, but in a parabola, you only have one. Either. Now, we are only going to be talking about what we call vertical parabolas, the ones that either open up or down. If you go on to further mathematics, you may talk about sideways parabolas. In those cases, the x will be linear and the y will be the square. In other words, if I had something like x equals ay squared, remember in our parabola, only one of the variables is squared and one is not. If it's the y that's squared, you get a sideways parabola. Again, we're not going to be discussing that in this course. If the x is squared, we get these what we call vertical parabolas. And the question is how, so let's erase this part. Even though they exist, we're not going to be discussing it. How can we get from our equation of the parabola to the graph of the parabola? And it's going to be, there are going to be two very important things to look out for, and a couple of things that, if you have time, you could do. The two important things is to find this point, or over here, this point, which is sometimes called the turning point, or the vertex, or sometimes, like in this case, this would be called the minimum point. Because it's the lowest point of the graph. Whereas on this one, this point is called the maximum because it's the highest point on the graph. So this point that is called also the turning point is basically the point where this is not a straight line, this is a curve. And what's happening is your curve is going down, 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 down. So we're going from left to right over here. We're going down, 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 down. And suddenly it turns around and we're going up. Whereas over here, we started, if we're coming from the left, we're going up, 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 up. We get to this point, suddenly we're going down. So this is also called a turning point. And it's also probably the term that I'm going to use the most is called the vertex. The vertex, and it's the same for either one of these parabolas, is probably the most important point that you want to find on your parabola. It's the center of the parabola. One half of the parabola is the image of the other, the mirror image. If I would put a mirror straight down here, one half of the graph would fall right on top of the other. It's once you know what the vertex is, and you know whether your parabola is an opening up or an opening down parabola, you will be able to do a pretty good sketch of that parabola. So the question is, how do we tell whether a parabola opens up or down? And how do we find this point called the vertex? So I'm going to erase this so I have room to work. Both of these are relatively easy to determine. To find if your parabola opens up or down, you look at the A. The A is the number that's in front of the x squared. It's going to be y equals, and then it's going to be something x squared plus something x plus something. You're going to look at that number A. When A is positive, your parabola opens up. When A is negative, your parabola opens down. So that's pretty easy to tell, and it's easy to remember. When somebody's positive, they usually have a smile on their face. But when somebody's in a negative mood, they have a frown. So just keep in mind, positive is a smile, negative is a frown, and you will remember whether your parabola should open up or down. Open up means it's a smile, opening down means it's a frown. Okay. There is a formula for finding the vertex. Remember, the vertex can be called the turning point, or the, in this case, minimum point, in this case, maximum point. As again, I'll usually use the term vertex. Yeah, you are, Brenda, that's true, but you're not supposed to be using that in this course. That would be on a graphing calculator. And you're really, I mean, I'm not in your house and I can't see which calculator you're using, but you're supposed to be only using a regular scientific calculator. Again, I'm not going to be standing over you and telling you put away your calculator, but that I'm going to show you how to do this without using a graphing calculator, especially since most of us don't have graphing calculators because it's quite expensive. If you have one, I'm not going to come to your house and say, hey, I'm confiscating it. So we're going to show you how to do this vertex by algebraic means. There's a formula that says x equals negative b over 2a. Remember what the a, b, and c are. The a is a number in front of the x squared, the b is a number in front of the x, and the c is the standalone number, the constant that doesn't have any x. If you take the b, negative b, and divide it by 2a, that will give you the x value of the vertex. It's only the x value, but remember, a vertex is a point. To find the y value, you substitute your answer into the equation. So there is a formula that allows you to find the vertex. So I'm going to let's demonstrate this whole thing by doing an example. Suppose I gave you the equation y equals x squared minus 6x plus 5. And I'd say I want to draw a sketch of this. Now, first of all, I recognize it as a parabola because I do have an x squared term, but I don't have any y squared terms. That must mean it has to be a parabola. A parabola has one of the variables with an exponent of 2, but the other one does not. Okay. I also recognize, let's put down what the a, the b, and the c are. The a is 1, because there's nothing in front. The lead coefficient is obviously 1. The B is -6, and the C is +5. If I want, I recognize the A is positive, so this is opening up. To find the vertex, I'm going to put x equals -b, which is -6 over 2a, so it's 2 times 1, which gives me +6 over 2 or 3. The x value of the vertex is 3. To find the y value of the vertex, I take this number 3 and stick it into my equation. I'm replacing the x now with 3. So this is going to be 3 squared minus 6 times 3 plus 5. Let's simplify this. 3 squared is 9 minus 18 plus 5. So this is 9 and -18 is -9. -9 plus 5 is -4. So now I know exactly what my vertex is. My vertex is the point x is 3, my y is -4. So when I want to draw a sketch of this curve, I really have quite a bit of information, enough information to do a pretty good sketch. How do I do that? I go to the point 3, -4. So here's 3 to the right, 4 down. And I know that this is the vertex of an opening up parabola because the A was positive. So my parabola has to look approximately like this. And it really should look the same on both sides. Very often, this is enough. If you're doing a multiple choice test and they ask you pick the right answer, this is often enough of a indication for you to pick the right one, because they probably on a multiple choice, they'll give you one that's facing down, they'll give you one with the vertex up here, one with the vertex over here, one with the vertex over here. So if you can pick out the correct vertex and the correct direction, you will have picked the right choice. So the most important thing to know about a parabola is its vertex and whether it opens up or down. But there are other things that we could figure out as well. And sometimes they do ask questions about it. One of the things they can ask you about is, what are the intercepts? Just like we found the intercepts on the circle, on the ellipse, and on the hyperbola, we might be asked to find the intercepts on the parabola. So the question is, how do we go about finding the intercepts? Well, on these vertical parabolas, it's always quite easy to find the y-intercept. To find the y-intercept is something that we actually did this method when we had lines. How did we find the y-intercept of a line? And obviously we could put it in the y equals mx plus b form, but we also could find it by replacing the x with 0. Any parabola is going to have exactly one y-intercept. To find it, again, we're going to take our original equation, which is y equals x squared minus 6x plus 5, and replace the x with 0. That'll give us y equals 0 squared minus 6 times 0 plus 5. Now this is 0 and this is 0, so we're left with just 5. If you think about it, the c is what you're going to get when you replace the x with 0. So the c, which is 5, is your x-intercept. I probably did not do this too well. I should have put it in first. Here's 5. 1, 2, 3, 4, 5. That is probably a better. Notice by putting in the y-intercept, I actually got a better picture of my graph. So that's to find the y-intercepts. The y-intercept is on any parabola is quite easy to do. It really is always the c value when you're talking about vertical parabolas. What about x-intercepts? Now, to find an x-intercept, you have to replace the y with 0. Remember, we did this actually when we did the lines. If I wanted to find the x-intercept, I let y equal 0. If I wanted to find the y-intercept, I let x equal to 0. That rule applies to any kind of graphing. It could apply to parabolas, to lines, to circles. Okay. So the question is, how are we going to find the x-intercepts? So I'm going to take this, we know our vertex. I'm going to go to this equation. I have to erase this. And I'm going to figure out the x-intercepts. Now, if you notice, this particular parabola has 2 x-intercepts. If the vertex would have been right on the x-axis, it would only cross at one point. And if the vertex was up here, we could have something like this without any x-intercepts at all. We'll always have exactly one y-intercept, but x-intercepts, we could have none, we could have 1, or we could have 2. Let's see how we find the x-intercepts. Remember what I told you to do. To find the x-intercepts, replace the y with 0. So we get 0 equals x squared minus 6x plus 5. In other words, we get a quadratic equation that we have to solve. Do we know how to solve a quadratic equation? Of course we did. We just had a chapter on it. Sometimes the quadratic equation is easy to solve. Sometimes it's more difficult to solve. Sometimes you can just use factoring. Sometimes you might have to use a quadratic formula. But to find the x-intercepts, that's what you have to do. You have to solve this equation. Now, this happens to be easily factorable. If you break it up into x and x, since the last term is negative, is positive, both sides are going to be the same, and the middle is negative, means both are going to be negative. And we need 2 numbers that multiply to 5 and add to 6. Obviously, it's 5 and 1. And then we set each of these equal to 0, so I get x minus 5 equals 0. So x equals 5 is one answer. And x minus 1 equals 0 gives me x equals to 1 as my other answer. In other words, I have 2 x-intercepts, one being the 0.50 and one being the 0.10. And let's see how close we got to this. Look at, here's 1, 0. I actually hit it. And here's 1, 2, 3, 4, 5. Here's 5, 0. Here are my 2 x-intercepts. So and this was the 0.05. So these are all the things they could find out about a parabola. Again, the most important thing is the vertex. That's absolutely the most important thing to know about a parabola, and also whether your parabola will open up or down. If the question asks you, then you should find either the x or the y intercepts. Again, to find the y-intercept, you replace the x in the equation with 0. To find the x-intercept, you replace the y with 0. Again, that will entail solving a quadratic equation. To find the x-intercepts, you usually have to solve a quadratic equation. Okay, let's see if I can give you an example to try. Okay, this is actually off of a final exam, so you'll get an idea of what they might ask you. I'm going to put it on the board, and then I'm going to start, while you're working on this, I'll take attendance. I'm just going to put this over here. The vertex, to get the vertex x value, do negative b over 2a. Here's my equation. Y equals negative x squared minus 2x plus 3. I want you to draw a sketch of this graph. Absolutely must find the vertex. See if you could also find the intercepts. And after you've done it, I'm going to give you the choices of what it looks like. But first, I'd like you to start working on this while I take attendance. Yesenia? Yesenia?
Here.
Good. Dominic? Dominic?
Here.
Good. Darlenis?
Here.
Abdul?
Here.
Good. Angelina? Angelina Bahari Lal? Angelina here? Yesha? Lucia? Ashley. Davante. Victor. Kizzy.
Here.
Okay. Jessica.
Here.
Okay, good. Ashanti. Ashanti. Shania.
Here.
Good. Anaya. Anaya Glover. Bernardo. Good. I see you're here. Tara. Tara. Karina. Karina. Asanta Hawthorne. Mary Ellis. Mary Ellis. Kalinda. Batu. Samaya. Monique. Letty.
I'm
Letty.
here. Here.
Brenda. I know you answered the question.
Here.
No, you did. Brianna. Brianna Minzy. Judy. Naira. Naira.
I'm here.
Samantha. Samantha. Amilta.
Here.
Oh, good. And Odalis was here. Actuvia. Wajahat. Kathy.
I'm here.
Okay, good. Wendy. John Edward. Alexandra.
I'm here.
Genesis.
I'm here.
Jasia. Jasia Schwabi.
And I didn't want to do that.
Jasia. Maya.
Here.
Good. Let me just check the chat if anybody said that they were here. Okay. I think we're okay. Okay. Let's see if we can do this example. Okay, first of all, I notice that the A here is -1, which means that this is going to be an opening down parabola. The A is negative, means it's going to look like a frown. Also, to find the vertex, I'm going to do x equals negative b over 2a. Now I know my a is -1, my b is -2, and my c is 3. So therefore, I'm going to get x equals -2, that's negative b, over 2 times -1, which gives me +2 over -2, which is -1. Now remember, that is not the complete vertex. That only gives you the value of the x of the vertex. The vertex is a point, so I need a y as well. So I take this answer that I got from this negative b over 2a and stick it into my equation. So this becomes -1 squared, because my x is -1, minus 2 times -1 plus 3. And simplifying, -1 squared is +1, but there's a negative here, so this becomes -1. -2 times -1 is +2 plus 3. So this gives me -2 plus 1 is 2 is 1, plus 3 is 4. So my vertex turns out to be the point -1, +4. And that's what I have to look for. If I were doing this as a multiple choice problem, I would look to make sure that I got the proper vertex and the thing opening down, because they'll probably give you, if they give you a choice, they'll give you one opening up and one opening down. You'll be able to eliminate some of the choices by just knowing whether your parabola is opening up or down. So here's my graph. I go to the point -1, +4, and that's my vertex. And therefore, my parabola has to look something like this. It should look more symmetrical on both sides. The minimum I should do to draw a sketch of a parabola is to find the vertex and then decide whether it opens up or down. I also ask you to find the intercepts. So let's do the intercepts. Remember, the y-intercept is the easier one to do. There's always going to be just one y-intercept, and you get it by replacing the x with 0. And when I put x equal to 0, I get y equal to 3, which is, as I mentioned, the value of the c. The y-intercept is 3. 1, 2, I'll get a better picture now. 3. That's probably a better picture. So the y-intercept is relatively easy to find. It's x is 0, y is 3. Again, usually in the equation, it's just the c value. Now, let's see if we can find the x-intercepts. Now, I know they're going to be x-intercepts because I've sketched this graph and I see it's crossing my x-axis in 2 points. To find the x-intercepts, and again, I've seen this as a question where it says find the x-intercepts of the parabola. If you want to find the x-intercepts, you have to go to your equation and replace the x with 0, the y with the 0. So what do we get in that case? If I go to my original equation and I replace the y with 0, I'm getting 0 equals -x squared minus 2x plus 3. Now this is a quadratic equation, and I usually like to have everything on the left side equaling 0. Also, I don't like to start out with a -x squared because it makes it much harder if I want to use the factoring method. So I'm going to bring everything from the right over to the left. I'm going to add x squared to both sides. plus 2x to both sides, and minus 3 from both sides. So that my equation will become x squared plus 2x minus 3 equals 0. And this to me looks like it could be factored. Remember, if I can't factor it, I can always use either, in this case, I could even use the completing the square method because I'm starting with 1, a leading coefficient of 1, and my x coefficient is even. Or I could use the quadratic formula. So in this one, I really have 3 methods that I could use to solve this equation. But the easiest method is the factoring x and x. This is negative, means one is positive and one is negative. And I need 2 numbers that multiply to 3 and subtract to 2. Obviously, that's 3 and 1. And since the middle term is positive, we need the larger number to be positive and the smaller number to be negative. So that gives me the x plus 3 equal to 0, gives me x equals negative 3, and x minus 1 equal to 0 gives me x equal to 1. And here are my 2 x-intercepts. X equal negative 3, negative 1, negative 2, negative 3. And the y-intercept is 1 right here. This is negative 3, 0. And this is 1, 0. Actually, I have been pretty close to that, even though, as you notice, by just drawing the vertex in the proper place gives you pretty much the right numbers. Again, the most important thing is the vertex and whether your thing opens up or down. That's what you have to know about a parabola. Your homework for Thursday is our examples 6 through 8. Also look on Delta Math to see if there is anything. I will give you, there aren't a lot of questions on Delta Math, but I will be able to find some questions for you that have to do with circles and parabolas. And don't forget, if you have not completed the Delta Math test yet, you must, to get full credit, you have to complete it today. In any case, make sure that you do your examples. Do everything that you are required to do so you get as much credit before you get into the final. Again, I will be sending you out notices to anybody who's missing something, but you really should be able to tell on your own. If you're missing work, everything has been opened up. The assignments on Delta Math that are not tests have to be done, but the mark you get on it is immaterial. It just has to be, I just have to see that you tried them. The tests you need it for a mark. So there are 3 Delta Math tests. There are about 13 different homework assignments. There'll be a couple of more before the term is over. There have been 2 tests on Blackboard, one being the practice midterm, which was considered a test, and if you didn't do it, you're missing a test. And the other one was the actual midterm, and if you haven't done that, you better get in touch with me because it's worth 10% of your mark all alone on its own. And there will be at least 1 more test on Delta Math and 1 more test on Blackboard before the final. There's going to be a practice final at least on Blackboard, and it's going to be considered as for a mark. Okay, have a good day. Anybody have any questions? Now I'm ending the session for everybody, and we will start with trigonometry next time.